People, hope we're doing well today. This is the last set of videos for our calculus readiness unit. And this is the last piece of what will be on your cumulative quizzes as we start the year. And these are Z problems, okay? If you look for Z problems, if you Google Z problems, you're not going to run into them. Or I mean, you may run into one. I got the name from another teacher. That teacher assigned these all the time, and that's kind of where I got the idea from. And so I just, teachers, go to these conferences and share ideas, and we steal them from each other, and that's kind of how it works. And basically what it is just solving for Z. So I'm just going to do a bunch of examples, and all it is just the accumulation of lots of different algebraic techniques and principles that you should be familiar with, all in the service of solving for a particular variable. So that's it. So let's start with x squared minus xy plus 4z is equal to negative 3yz plus 5. Now, if I want to solve for z, I need to notice that there's not one, but two of them, okay? And in order to solve for z, I'm going to need to get all of the z terms on the same side. So we'll shove this one over here to the left-hand side. And all of the non-z terms I need to push to the other side. So this winds up being 3yz plus 4z is equal to 5 minus x squared plus xy. And all I've done is just collect all the z terms on one side and collect all the non-z terms on the other side. Now from here, I need to factor out, or what I've called before, undistribute the z. And now that I've undistributed, I have a single z. Now here I had two z's, so I couldn't, there was no way of me actually from this form solving for z. But from here, if I factor it out, I now have a single z as a factor of this left side. And in order to isolate it, I simply have to divide by what it's being multiplied by. And there you go. And that's it, okay? And a lot of them will be of this form, though some of them will be tweaked a little bit in terms of the form, just to make sure that you are paying attention. So for example, if you have, x, z minus y plus 4 is equal to x plus z over 2. Okay, well, this one was like the one before it, except, like in the fact that it has two z's, but it has one more layer of complexity in the fact that this z is basically tied up inside of this set of parentheses. Well, break it out of those parentheses, right? xz minus xy plus 4. And here's the thing, this is divided by 2. Now remember, this is not a variable in the denominator, so I could actually just call this 1/2 x plus 1/2 z, and then collect them. But here's the thing, I don't like fractions when I don't have to deal with them, so let's go ahead and multiply through by 2. Sound good? So I have 2xz minus 2xy plus 8 is equal to x plus z. Let's collect all the z terms over here on the left-hand side, all the non-z terms over here on the right-hand side. We'll go ahead and factor out a z, okay? X plus 2xy minus 8, and then of course what we'll need to do is we'll just need to divide both sides by this 2x minus 1, and I get x plus 2xy minus 8, all of that over 2x minus 1. Okay, so remember, and this goes back to what we were talking about before. Just because you can distribute doesn't mean you should distribute. In this case, you should, right? You need to, you have to, in order to get that z freed up so that you can start moving terms around, okay? But again, we need to ask ourselves the question and not just rely on sort of when you see this, do that, instinctual sort of procedure-driven logic, okay? All right, let's go ahead and let's do one that is set up as a proportion. Now this one winds up being really, really easy because there's only one z. Now, I know that your Algebra 1 brain is sitting there and it's looking at this and it's saying, I really need to cross multiply. Now, if you cross multiply, can you get the right answer? Sure, but it's unnecessary, right? Because there are no z's over here to be freed up. So I could just multiply both sides by 3 plus y. Couldn't I? That makes things a whole lot easier, because if you cross multiply this, and we'll do it here in just a second, it's a bunch of extra steps. And then I'll just subtract 1 from both sides. Now, is that a legitimate answer? Yeah, you got z by itself. Now, I mean, part of your Algebra 1 brain is sitting there and it's just reeling from the fact that basically I haven't gotten a common denominator and it doesn't look as simple as you would like it. Okay, well, it doesn't have to be. It doesn't have to be in any particular form. I haven't asked you to put it in any particular form. I've simply asked you to solve for z, okay? Now, if you were to cross multiply, here's what happens. You get, 1 plus z and 2 minus y is equal to x minus 2 and 3 plus y. But here's the thing. At this point, because you've cross multiplied when you didn't need to, you're probably going to FOIL when you don't need to. And that just opens up, a whole lot of problems and potential for careless errors, but let's go ahead and do it since we're following our Algebra 1 brain at this point. So first, outer, inner, last, first, outer, inner, last. Okay, well, I have two z terms, so this becomes 2z minus yz is equal to, okay, I'm going to add y to both sides, so that's going to combine with this. I'm going to subtract 2 from both sides, so that's going to combine with the negative 6. But the first two terms actually don't get affected. When I subtract 2 from both sides, that negative 6 becomes a negative 8. And when I add y to both sides, that negative 2y just becomes negative 1y. And then I can factor out a z, and I get 2 minus y, and that's 3x plus xy minus 8 minus y, and z is equal to 3x plus xy minus 8 minus y, all of that over 2 minus y, and that probably is making you feel a whole lot better, except for the fact that it was more than twice as many steps. Okay, which way would you rather do it? I would rather stop, think, and then do, and deal with fewer steps, because the fewer steps you have and the fewer strokes of the pencil that you have down here, and the less notation you have, the less chance you have of careless errors creeping in. Now, if you were to actually go back to this original answer and multiply this out and then get a common denominator and combine it with this one and push it together and collect like terms and blah, 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 you would get this. Those two boxes are equivalent. That is what I would prefer to do. But, do your thing. I would, however, like to warn you that the more you indulge that Algebra 1 brain of yours and do things just because you can, the harder it's going to be in the future to turn that off, and you actually do occasionally need to turn that off, right? Sometimes it's a matter of preference. Sometimes it makes it easier. Sometimes your Algebra 1 brain, however, will get you into trouble by basically changing an expression out of a usable form into an unusable form, and that's where you really get into trouble. Now, this one right here, we see the fact that the z is not only wrapped up inside of a rational expression, it is also underneath the radical. Now, in order to undo the radical, I need to square. But before I square, I need to get the radical. I need to isolate the radical. If you remember radical equations, Sorry, that's not right. If you remember radical equations, you need to isolate before you square, because otherwise this is a functional binomial here on the left. If you square the left-hand side, you have to square the binomial, and not only is that difficult, you haven't solved the real problem, because you will still have a radical to deal with. Okay, the only way to actually get rid of the radical is to isolate it, then square. Now that I have it here, it's not supposed to be a y. I keep doing that. Okay, x plus z. So I need to square both sides, and I get x plus z over 2 is equal to xy plus 1 squared. And again, your Algebra 1 brain is going to want to multiply that out. I guess you could, but why in the world would you want to, right? If you just go ahead and leave it like that, it winds up being so much cleaner, and of course fewer steps. Okay, let's do another one. Yeah, let's do that one. Okay, so let's say I have x over z minus 3x squared plus 3y over z is equal to 6. Now, obviously, there are two z's. They're both in the denominator. Now, I can do this a couple of different ways. I can, if I want to, just multiply both sides through by z. That's a perfectly legitimate way to do it. I wouldn't do that first, but you could, okay? What I would do first is I would get this 3x squared over to the other side. Because the moment you do that, you basically have two fractions with a common denominator, and that winds up being x plus 3y over z. Now I can multiply both sides by z, and the benefit of doing it this way is the fact that I now don't have to do any of the factoring out. Sorry about that. I don't have to do any factoring out because the z was never multiplied by each and every term. I can just go ahead and keep that keep the z undistributed and divide by that factor, and done. Okay. So again, a lot of it has to do not with what is legal or illegal, but what is strategic and what is not strategic, or what is most strategic, right? Let's go ahead and look at one like this. Now, the problem in this one is the fact that not only do I have more than one z, one of them is squared. Well, notice that I left a space there. That should be a huge hint as to what direction I'm going with this, okay? And the direction I'm going with this is, in order to get a single z, what I really need to do is I need to complete the square. And once I've done that, I have the ability to get z by itself now, and I simply need to take the square root of both sides, remembering to do the plus or minus, and then I add 4 to both sides, and that is my answer. Now, maybe some of you didn't actually see that completing the square, but that's yet another one of those algebraic techniques that needs to be not buried way back in the back of your mind, something that you only reach for when you're actually solving quadratic equations that don't factor. It is a resource, it is a tool that can be picked up and used strategically, of course, at other times. I'm gonna go ahead and call this video to a close, and I will do one more video on literal equations. I will also be posting a a worksheet of about 20 questions with an answer key that will also be a resource for practicing these Z problems or literal equations, and I think that will help a lot as well. If you have any questions, please do shoot me an email. Bye.